Hello everyone, and welcome to our first online video of the Architectural Plans and Specifications course. This first intro video will cover a little bit of the Talon details, as well as some external information on websites, pictures, and whatnot. But towards the end of this video, we hope to get into breaking down that first set of the ranch plan. So to start us off, we're going to make sure that everybody can get to the course content on Talon. Everybody's familiar with accessing it to this point here. Once we're here, if you go down to Residential Ranch and you click on this tab here, you should see these documents pull up over here on the right. The top one here is a PowerPoint of information. Certainly I want you to take a look at that. And the second one here is a website on the ranch. These two details, these two files right here are very important, especially if you don't have a lot of experience within residential construction. This will help you quite a bit. The rest of the files down here are the plans for the ranch. The first one here is a complete set of plans. So what that does is it includes everything below it, from general notes all the way down to main floor electrical. So all of these individual plans, as I said, are part of the complete setup here. So first and foremost, let's start off with these two pieces up here. So the first one, construction details. If you click on that, you're going to see this PowerPoint pop up. And as it shows you here in the pictures, it shows you a typical wall, wood frame wall section here in the ranch. So we have a full basement underneath, as you can see here. And I'll break down these parts here as we go. We can see that we have this is our concrete foundation wall that sits on top of a concrete footing. You guys are probably familiar with the word footing before. Again, that sits at the bottom of the wall, gives the support for the entire building. Then off of that footing, you can see that we have our basement floor sits on top of 4 inches of rock, some insulation, and some vapor barrier. And when we get to the section views of the actual print, you can see the detail in that a little bit better. So that's on the inside of the basement. On the outside, we have this weird looking little circle here. That is your drainage tile. And that tile is typically a 4-inch perforated plastic tube, basically, that goes all the way around the outside of the footing. That drains into the house. Actually, we encourage that water to come in for a non-walkout basement like this one into what's called a sump pit. And you guys are familiar with the sump pump. Well, inside that pit is that pump that will pump the water out. So you guys know when you get a heavy rain, a lot of times you hear that pump turn on, and basically it's taking all the water that comes down the side of the building that ultimately collects into that tube. It's pumping that water back outside. As we move up, you can see that our floor joists, or wooden floor joists in this case, sit on top of that foundation wall, connected with the rim joist out here, or sometimes called a band joist. On top of the joist, we can see that we have subfloor, usually 4 by 8 foot sheets of OSB or plywood. And then on top of that, we start our wall. You can see here that we have just a 1-story, so just one level of wall here. The bottom plate, the studs, the top plate, double top plate. You'll learn more about these in other classes, but that's the gist of the structure there. Then ultimately, we get all the way here to the top of the wall, and that's where the wood roof trusses sit. So they actually have bearing, or they have weight on top of the wall here. That weight comes down, transfers that weight on top of your floor system here. Floor system then transfers it down on top of the concrete wall, all the way down to your footing. So that's why the footing is so important. A lot of times that's where we start as we figure out then obviously the weight above to see how big that footing has to be. So that's that part of the structure. If we click the down arrow, we can see a little bit more detail. Here again is the footing, the wall. This is our rock, or our base material, typically 3/4 inch gravel. So like what you see on gravel roads is what we put down here. We compact that the best we could. And then this next blue layer is insulation. Now, either before or after that level or layer of insulation, we should put in what's called a vapor barrier. A vapor barrier is typically 6 mil in thickness, but that is the way to keep moisture that is inherent within the dirt and the earth below from coming up into the slab of concrete. So it keeps the moisture from the earth out from coming up into that concrete floor. Here also you can see on the outside of the footing is that drainage tile we talked about before. So the picture you're seeing in this is the exact foundation that was poured for this ranch plan. And what you'll do is get familiar with the front door being right here. Approximately here's your stoop. It's our front porch. All the way over there is our garage. You can kind of see the cutout right there. That's for the two-story two-stall entrance to the garage. Our kitchen will sit about here. Bedroom number 3, I believe, is here. Bedroom 2 is back there. And then our master bedroom is clear back here in the far back corner. But again, as we get into the plans, you'll see that a little bit better. Some other things in terms of structure, you heard me say earlier about the studs of the wall. That's these pieces here. We also have something called a header. And a header is when we have an opening below it that we don't want studs to be through our window. So we've got to find a way to get the weight of the roof, in this case, that's above that wall, to go out, away from the window in each direction. Okay, so this big chunk of wood called our header enables the loading of the roof above to come down to the header, and then it spreads it out this way and then down the studs, like I say, all the way down to the footing eventually. This next picture is probably one of the hardest for people to really understand, and quite honestly, it's one of the dumbest designs we've come up with, in my opinion. It's so hard to regulate ventilation in attics. If you guys know, you've been up in the attic in the summertime, it's just boiling hot, 100 and some odd degrees up there. And what's supposed to happen is that cooler air is supposed to come in through what's called our soffits here, come up inside that attic through natural ventilation, because hot air is supposed to rise quicker than colder air, is supposed to rise and vent out of the top. Well, the problem is these need to be balanced. Your intake here should meet the exhaust, so every square inch of intake should have the same square inch of exhaust. Typically, especially how complicated our roofs are anymore, it's very difficult to achieve that. Sometimes you can put a power vent on there, actually pull the air out, but then again, that has to match the intake. So this is often not calculated by designers and builders. It's just kind of an afterthought. And if you get 100 and some odd degrees up there in the summertime, you're trying to keep your space below that to 70 some degrees. You've got to now cool that much more, because that heat will work its way through the insulation and try to get into the house. So often misunderstood, often not done correctly, and there are alternatives to this now. We'll discuss a little bit later in the class. Next pictures are the exact framing pictures of the house as it was going up. You can see that we've got the walls up in this picture. We've got the trusses on. We're about ready to finish sheathing on the trusses. What I like about this one here is, and I know it's kind of hard to see, but you'll see on the plan, these are called scissor trusses. And scissor trusses have a vault to them so that we got a high point up at the very top of that ceiling, and then slopes down to the walls, gives more volume in that space. The next picture here shows some of the detail of that ventilated roof that we looked at just a minute ago. These are called ventilation or attic chutes. And the theory behind that is that we staple these to the underside of the roof like this, of the OSB, and they go continuously all the way down to the overhang outside. And as we pack insulation into that cavity, we're supposed to be letting, again, this is kind of ridiculous, but we're supposed to be letting the cooler air then bypass the insulation, stay inside these chutes, and then ultimately cool off the attic above. Detail here, and this is something that students often get mixed up, is the difference between, well, first of all, how an eave or an overhang is constructed. Here's our roof truss, right? We got that here. And we come out here to the edge, and we have this 2x6 typically of what's called a fascia, or technically it's your subfascia. And fascia is the vertical part of this overhang system. Okay, so a piece of wood gets attached to the truss, and then on top of that we'd have our fascia cover, which in most residential applications is aluminum, and it's pre-painted, so you don't have to get up there and paint it. So that again attaches at the tail or the end of the truss. And then your soffit, so fascia is vertical, soffit is horizontal. And this material here, again, is typically made out of aluminum, pre-painted, so you don't have to get up there and maintain that. And then your gutter on the overhang that comes down to the fascia like this scenario, this overhang, your gutter would attach to the fascia. Here's a picture of the front door and the windows that are on either side of it, as well as the concrete for what we call the stoop. So your front porch, if it's concrete like that, typically people call that a stoop, S-T-O-O-P. You see a little bit of detail for flashing. We want to make sure that if water comes down this wall, ultimately it gets on top of that flashing, doesn't work its way back inside the building. Here's another picture of that with a few finishes on it. We can see that there's more flashing detail with Tyvek and some of the tape around the windows. Flashing again here down by the brick onto the concrete. We have what's called our first coursing of brick put down. And when you see brick that is stood up like this, and the skinny part faces out of the brick like this, that's called a soldier course. A sailor course would be to turn those bricks 90 degrees, so you get the wider face pointing out. So again, some good Tyvek, some good flashing details that are here. We'll discuss more of that in that residential construction class. Something you may not be aware of is when you get to the top of an opening like this window here and you've got brick on the face, you have to put in what's called a lintel. You guys can see that right here. Lintel is a big chunk of metal, like an L-shaped piece. So part of it gets attached to the building and then the other part sticks out like this. Well, eventually we will continue to put brick all the way across that. So this is like a header. If you remember from earlier with the wood frame structure, the header supports the weight above. Well, a lintel supports the weight of the brick above that. If we go on to slide 13 here, you're going to see a little bit more detail of that. Now you can kind of see how that front's going to look, and this is a SketchUp file, obviously a rendering from that. Here's the actual before the brick went on it. And in both cases, you can see how the trusses extend out. That's called a cantilever. So cantilever is when the actual bearing or the load of that truss is way back here, and we just have this huge tail on it. Obviously, we put that on there for the porch to keep the weather off of us, but this part from where it stops at the wall to where it extends out about past the porch, that's called a cantilever. And here we can see some of the finished product. So on the top left there, you can see how the siding, the roofing, the gutter work, soffit and fascia, and all that came together. Obviously, garage door. This would be your laundry room door. You'll see, or laundry room window. You'll see that here in a little bit. And then the back deck. The framing for that is started. We can see our post here. We got some floor joists coming out. We've got the beam coming across right there. So this segues into that link that's right below this on the course content. You can also click on that if you'd like, if you download the PowerPoint. But for us, what we're going to do is we're going to go back to the class, go to course content again, and go to Ranch. And then that website is right here. So if you click on that link, it's going to open up this new website. And I really, really encourage you guys to take a look at this. It's very rare that you get to see not only the plans and the specs for a building, but you also get to see the pictures of how that building went together from start to finish. So if we start on August 20th, that was a particular day that they started digging the hole for the foundation. This is looking from the back side, the backyard, looking towards the house. You can see all that dirt that was cut out. Nice black dirt. People would be envious of having that. And then if you just go down the bottom of the page and click next, it keeps going step by step through the whole process. You can see the gravel driveway was put in so that workers had access to the site. And if you look below, you can see that the footings are put in, and these metal pieces sticking out of those concrete footings that's called rebar. And what that does is it ties, concrete will eventually be poured around that for the wall, and that ties the wall to the footing. So I'm not going to go through all of these pictures, all these slides, but I really want you to take a look at it. There's good descriptions of what you're looking at for each of the pictures. So definitely spend some time looking through there. It certainly will help you, I think, as you continue working with these plans. So if we go back to talent here, go to our course content, the next thing then is a complete set of plans. And if you click on those and you get those downloaded, you can do that here. And to download them, what I would suggest is coming right down here to the bottom of the page, hit that download button. It will pop it up. I'm on Chrome right now, but it'll pop it up in your downloads. Click on that to open it. What I like about the Adobe after downloading is you just have a few more tools that you can use. You can zoom in, save it, print it, and so on. So the first sheet, we're going to do probably 3 or 4 sheets today. And probably one of the most important but often overlooked sheets is the cover page. And it's going to tell you a lot of information about the overview of the building. So again, this one's called the Creek Residence. If you're building a house for somebody or designing for somebody else, you might call it by their last name. So the Jones Residence or the Great House Residence, whatnot. In this case here, we can see this sheet organizes it by building data. And it tells us that the gross building area has a conditioned main level of 1,375 square feet. That's the SF. It has what's called a conditioned lower level of 450 square feet, and of course a garage then of 400 square feet. So if somebody says to you, and this is often confusing, somebody says, oh, I live in a house that is 1,375 square feet. Well, does that mean they're talking about the main level? Does that mean they're talking about the main level plus a little bit of the basement if it's finished? And what does that talk about? I've even heard some people include the garage square footage, which is very ridiculous, I think. So a lot of times, in this particular case, somebody could say, yes, I live in a house that's 1,375 square feet. And some other person might say, well, I live in a house that's 1,825. Basically, the 1,375 plus the 450. Well, both are correct. It just, again, it just depends upon how the person is obviously speaking of that square footage. Now, the word that I really want to hone in here is called conditioned. And so how most people, especially the tax guy, the person that's going to tax you for your real estate taxes, what they're looking at is, are these rooms heated and or cooled? And by definition, any room that has heat in our climate is called conditioned. It doesn't have to have air conditioning. In fact, many of you probably either know or grew up in a house that didn't have air conditioning at some point or whatnot. Even though it didn't have air conditioning, it's still considered conditioned because it had heat. So in this particular case, we have a total of 1,825 square feet of conditioned space. The garage may or may not be conditioned. If it is, great. Technically, it is conditioned space of the house, but most people do not count that in the quoted square footage of the building. And then right underneath that, we have what's called structural notes. And this is done typically by an engineer who would specify such things as soil bearing pressure. In this case, they're saying that the footings, the concrete footings at the bottom, have to withstand at least 2,001 pounds per square foot. That's at PSF. So if you think about a square foot, basically the size of most people's shoes, you look at that size and you say, okay, if I went down to the footing, I ought to be able to place 2,000 pounds on that size, 1 foot by 1 foot of footing, and not ruin or crush the footing and not sink into the earth. So a lot of weight. I mean, that's almost a small car that you could put on top of that. 2,000 pounds is 1 ton. So 1 ton of weight in that particular spot. The isolated footings are the same thing. Now, if you go to minimum concrete strengths, so now we've moved away from soil, we're looking at concrete, we can see we got to have 3,000 PSI. So we got to pour the concrete more than the dirt. And sometimes I guess that makes sense, right? You don't want to crumble that concrete, obviously, before it gets to the dirt. It's got to be able to hold that. So our footings are 3,000 PSI, pounds per square inch. That's the type of mix that they use. And that's cured at 28 days. What they say with concrete, and again, you'll learn more about this in other classes, is the hydration process, how concrete cures. A lot of people say, oh, concrete dries. Well, it kind of does dry, but really what's happening is at the molecular level is curing. Okay, and it takes about 28 days to reach a level that is close to the strongest level it's ever going to be. So they always specify that as 3,000, in this case 3,000 PSI at 28 days. The mortar for the masonry is there, the grout's there, the reinforcing steel, otherwise known as rebar. We talked about that a little bit ago. Gives the specification for that. And then the welded wire fabric, that sometimes gets confusing. People might understand rebar, they've seen that before, the reinforcement bar. But the welded wire fabric typically is used in flat work. And flat work means that like your basement floor, your garage floor, sometimes driveways, patios, that type of thing, things that are horizontal like that, is like rebar, but it's really thin. It looks just like a wire fence, not like a chain link per se, a little bit thinner than that actually. But the squares in that fence might be 6 inches by 6 inches or 4 inches by 4 inches. We're going to see that detail when we get to the section view of this particular house. And then anchor bolts, that's what connects the concrete to the wood structures of the house. So the top of the foundation wall is going to have an anchor bolt in it that goes through and connects that wood plate. Talks about wood engineered trusses, sometimes called TJI. Now that's a trade or a company name, Truss Joist International. But kind of like Xerox and Kleenex, that's just a company name that people attribute to that particular type of truss. Talks about floor deflection and such. We're going to break more of this down as we go in and talk more specifically about products, but in essence, that's where you're going to find that information on that very front cover page. Then right below that, we can see the schedule of drawings. Very important, especially when you get into big drawings where there's hundreds and hundreds of pages. And this one, there's just 10. You know, cover sheet being the first one here, all the way through the site plan foundation, all the way down to lower floor and main floor electrical. Now, I would tell you, in all the years I've been building houses, the electrical plans are, if there are electrical plans or plumbing plans or HVAC, they're often not very descriptive. I mean, it's just kind of a guess on the designer's part. Usually you don't have an engineer specify what that is. So don't be surprised if you look at a set of residential plans and all you see is basically 1 through 7, or 1 through 8, sorry. They may not include the electrical or plumbing or whatnot. If we go back up here to the top right corner, we got our general notes. And again, there should be some specifications accompanying these drawings. So you know, when you're looking at the drawing, you say, "Oh, I see the bathroom vanity there. I see it's a 3 foot or 36 inch wide vanity, but if I'm going to go buy that so I can install it, what kind is it?" Well, you would find that type of information in the specifications. Second one here says all construction is to be in strict accord with governing codes. You guys have heard of building codes before, I'm sure. So in this particular case, this house was built in the city of North Liberty, so not too far from us. The jurisdiction for code enforcement for that town is its local building department. Okay, so in that particular town, somebody would review the plans, make sure that they meet the criteria the building department's looking for, and then every so often, 5-6 times during that build, the inspector from the city would come out and look over your project, make sure it's meeting the design, and make sure that materials are meeting the code that's set forth. Now, the code that they abide by is called the International Residential Code. Sometimes you guys hear that called IRC. And the IRC is going to tell the inspector what type of materials are okay, what type of spacing for your studs are okay, what kind of connectors, nails, screws, all that kind of stuff. So they're going to go through and verify to make sure it was built according to that code. Next one, concrete, again, should be inspected for your footings, your walls. Make sure it has rebar, the structural pieces it's talking about included. Number 4 then talks about fixtures and appliances, and it says to be selected by the owner. Well, in this particular case, we knew, and I didn't build this one, but the contractor knew who they were building this house for. So they had a client. The client then had the ability to start picking out some of the finishes that would be in the house. So in this case, fixtures, appliances, you'll see as we go along, the flooring was also specified by the owner and such. So typically in a house, an owner, if you have one, that's called a pre-sold house because you've got a client. In that case, the owner typically would pick out such things as fixtures, so your lighting fixtures, your bathroom fixtures, possibly, paint, flooring, appliances, I mentioned that. Those are the big ones. Now, certainly they have the ability and authority to pick out everything if they want to. Siding, shingle color, soffit fascia, gutters. I mean, they can pick out everything. But at some point, most clients say, you know what, to the general contractor, we want good value, good quality, blah, 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 that type of thing. And they allow the contractor to take some of those considerations on themselves. Number 5 then says all manufactured products materials should be used in accordance with manufacturer's recommendations. So that basically just says don't put materials in to do something they weren't intended to do. Number 6 says don't scale this drawing, and scale is a very important thing. And I hope to remember before the video ends here to show you where those videos are and how to use a scale, because we do have them here on Talon. So you should, in this case, since you can't put a scale to it, you should trust, as it says here, all dimensions are to rough construction unless otherwise noted. So if it says that this wall is 8 feet 1 inches, that's what you should believe. And lastly, number 7 says protect existing construction to remain. Verify landscaping requirements with other. So last part first, landscaping. Again, because it's a pre-sold, the homeowner is going to come in and help pick out, decide what that design and that construction is going to look like. And then protect existing construction area. And this not only falls to the drawings, but it also falls to code. A lot of times when you have, say you do an excavation, you dig out for the foundation, you have this big hole in the yard, and you got neighbors on both sides of you. Well, typically, you want to protect that from people getting hurt. The other thing you want to do is not just the hole for the excavation, but you want to protect the site from neighbors coming in and accidentally getting hurt. So you might fence that area off. Okay, moving down here, we have something called a schedule. In this case, it's called a room finish schedule. And what it does is it really quickly gives you information about how the finishes, and finishes would be like, say, drywall and paint and carpet and wood floor and tile, that type of thing. So if somebody said, you know what, do we have carpet in the master bedroom? Well, you could go look at the plan and it might have a note there, or you can come to the schedule and you go down to master bedroom right here. And it says flooring is carpet, the base, and that's your base trim that goes around the edge of the room, is wood. And then it says walls is GYPBD, that's gypsum board. Trade name for that would be drywall or sheetrock. And then it is PTD for a finish, that means it's painted. So that's our walls, and our ceiling is the same thing. It's gypsum board and it's painted. And then in this case it gives you a nominal height. Nominal means its name. I think that's Latin. So for an example, if I say, go hand me that 2x4. Well, you guys know what a 2x4 is. If you'd actually go pick it up and you'd measure it, you'd find out that a 2x4 is only 1.5 inches thick by 3.5 inches wide. So we don't call it, we don't say, go pick me up that 1.5 inches by 3.5 board. Again, the name or the nominal dimensions is 2x4. So when they say a nominal height is 8 foot, 0 inches, the actual height's probably closer to 8 foot 1 inch, somewhere in there. And we'll discuss in this class as well as other classes why it's kind of an odd measurement. But we say it's an 8 foot wall. So that wraps up that page. Let's go down and take a look at the site plan, which is this guy right here. And we're going to start at the street. I like to get, bearing, how the house sits out according to the road out front. Now, this particular road is called Tantera Court. And if you look closely, you see this little line here at the bottom. That's actually the curb of the street. Okay, now, you see this dark line? It's a few feet behind it, this dark arch. Well, that arch right there, that curve, that matches the curb on the street. Makes sense, right? So the first question most students say, well, wait a minute, if the curb is up here, isn't this my property in between the curb and this line here? Technically, no. If you're in a city development, such as this one was in the town of North Liberty, as others, the grass and the sidewalk, because here's your sidewalk right here, the sidewalk and the grass actually belongs to the city. Now, you have to shovel it, you have to mow it, you get to do all that fun stuff, but ultimately If the city wants to do something with that, that's their property. They can come and do what they want. So your property typically starts right after the sidewalk. In this case, you see that arc right here. And then if we extend that black line back, you see how that comes back to this point up here. That's your back lot pin. A lot pin is a location of this point right there. You'd have another lot pin right here, here, and here. Now those lot pins are set up by an engineer, typically a civil engineer, that hires a surveyor, or maybe it's their own company, to come out and locate each of those corners. Again, that's your lot pins. So you knew exactly where your property starts and stops. And then within that lot, now we're going to locate where our house is going to be. Now this is very important, sometimes often overlooked and certainly not understood a lot of times, is you can't build anywhere you want inside this lot. Usually the city comes has codes or guidelines to tell you where on that lot you can build. Now these are called either easements or they're called setbacks. You see the word setback right here. Let's start with that. So it says here, and this lot's kind of confusing because it's a pie shape, but it's considered that this is our backyard. Kind of as it comes up and turns a corner, this area would be considered backyard. And in this particular town, the ordinance is that the setback distance from the actual line of your lot to the line that you can build. So anywhere within this dashed line right here, we can build our house. We could have put the house clear back here if we wanted to. But the setback says that you can't build any part of your house closer than 25 feet to the property line. Okay, that's called our setback. Now, if you look over here in the very back of the back right corner here, we still maintain 25 feet. So 20 plus 5, right? That's 25 to our lot line. But now there's something called a utility easement. So setback and easement. An easement says that, okay, even if it's in your setback like this, you can't build anything permanent within an easement. So for an example, we got two things back here. We got a garden and we got a trellis swing. Now those are not permanent structures, attached to the house. Those are things that could be moved if they needed to. So those are okay to build within the setback area, but they're not okay to build within the easement. Now this is a utility easement. What that tells me is there's probably electrical, maybe phone wire, cable TV, maybe even natural gas line that goes in that area. So let's say it's electrical, for example. Alliant Energy, if that were the utility company, they might need to come back and service that wire. Maybe there's a break in it or whatever. They need to have access to that area. So you have to reserve that space for them to come in and do that work. So you lost your land up here by the street. That's not yours. You lost a little land over here, and if you look carefully, you see that easement turns the corner. And you've got a 5-foot easement down this side over here. So even though it's your land, you kind of got that interrupted a bit, right? Now, so 25-foot setback in the back. What's our side setback? Sides being this side and that side. Well, if you look closely here, you see it's less than 25. It's only 10 feet. So this corner of the house right here is only 10 feet drawn perpendicular to the lot line, 10 feet off of that lot line. This side over here, the closest thing is the garage. If you look at that point right there, 10 feet is that dash line, so we're a little bit further, exactly 2 feet 9 inches farther away from that setback right there. So our house is located correctly, or it's within its limits in terms of what the setbacks and the easements are. Like I said earlier, we could have took this house and we could have moved it clear back in this location right here. And that would have been fine. Our neighbors might not have liked it because it doesn't match what they did. I mean, most houses are pulled way up front. What that does is gives you a shorter driveway, makes you more neighborly too, so you're not clear at the back of your lot, and then keeps the neighborhood looking uniform when you pull it forward like that. So in addition to lot lines, setbacks, and easements, other information on here is obviously the outline of the house, the outline of your driveway. You can see that right here. It's a poured concrete drive. Here's our service walk that goes up to the front house. And you guys remember this in the PowerPoint. Here's our front porch, or our stoop is right there to get into the house. The back deck needs to be located. So anything permanent like a deck attached to a house has to be located on the site plan. And then we have our gas meter, our condensing unit, that's what the CU stands for, and the pad below it, usually plastic or concrete. Up front, some more abbreviations. MH, we got a manhole, and that kind of stinks, to be honest with you. Right in the middle of your lot, you got this curve here, you got that manhole to deal with. And it caused some problems for this house, as you can see, because what did they have to do to their driveway? So the driveway comes down like this, goes right down here straight, and if it would keep going straight, you'd run into your manhole. Well, that's not good. So you got to take that driveway and you got to kind of veer it in a little bit like this to go around that. So you actually took your 17-foot driveway up here and you condensed it down to 13 feet here. That's not very wide and kind of a hassle, to be honest. The other thing that makes the driveway kind of complicated is you see this right here, it says existing storm sewer inlet. Now most codes say that the edge of that inlet, you have to be 1 foot minimum away from that before you can start your driveway. So this driveway was really squeezed. It was squeezed in between this inlet here and squeezed in between that manhole there. So some conditions you got to look out for. And then lastly on this one, a couple things actually. Slope, you can see it defines that the water drains away from the house. That's a good thing. And then the last piece here is you see these funky little numbers here. S, 27 degrees, 22 minutes, 30 seconds. That's what those dashes are, west. And then it gives the last number here of 126.84 feet. So we'll start with that one first. It's 126.84 feet from this lot pin here to this lot pin up there. And this one would be 61.91 feet from here to here, as you can read there. And these other letters and numbers, that gives you direction. So if I'm standing here, it's going to, if I understand surveying, which you guys will here shortly, you have a class in that, it would tell you which direction to start measuring. So using this information here, plus the dimension here, it would tell you how to locate that pin. And then you kind of work yourself all the way around. The site plan here has a scale of 1 inch to 20 feet. So the way it's represented on this sheet, every inch that you see, as it says here, is actually 20 feet in real life. Okay, so moving on, we're going to do one more print here and then we're going to call it a day. You got enough information to get you started in your worksheets. So this is, as it says right down at the bottom, main floor plan. We can start with that. And you can see that our scale changed. We see that we're 1/4 inch equals 1 foot 0 inches here. So different from what you just saw in the site plan. First thing I'd like students to do when you look at a brand new plan like this one is definitely figure out how you get into the house. So the first thing I usually tell students is find me the front door. Well, there's some clues on this one, right? We can see that we've got a driveway, and of course we know about the sidewalk, and it comes up to the front porch. So our front door, assumably, is right off that porch, and here it is, right? So now what I want you to do is take a couple seconds here and pretend that you walked in the front door. And what I want you to do is try to visualize in 3 dimensions what you're seeing in 2 dimensions. So when you step in that door and you're kind of looking around, what are you seeing? Are you seeing a wall in front of you? No. You're looking straight on, coming in that front door, you're looking into that living room. You're looking at that fireplace, kind of kitty corner there in that far corner. And you're looking into the dining room. If you look to your right, you see a closet. If you look to your left, you're kind of looking down a little hallway. You see the door then to the stairs that go down. If you follow that hallway, you look to your right, you see bedroom number 2 in the back, bedroom number 3 up front. Of course, we got our bathroom over here. Go back down the hallway, we got our kitchen. A door that gets us into the utility room. which then connects to the garage, kind of like a little breezeway or mudroom. And then if we go back out this way through the dining room, we get into a little vestibule. It's just like a little transition space then that opens up to the master bedroom or goes to the walk-in closet here. And then lastly, through the master bedroom, we can get into our master bath. Of course, the tub, toilet, sink. So, and our back deck, of course, that's right off the dining room. This is a sliding door. So now that you know the gist of the layout, now what I typically do is I start in a corner. I'll probably start in this corner right here. And I work my way around the house looking at abbreviations, looking at other symbols, excuse me, to try to get you guys better acquainted with that nomenclature. So if we start at this front corner here, and I'm going to zoom in a bit so you guys can see that better. I start at bedroom number 3. First thing I want you to notice is that we have 2 dark lines, kind of outlines the wall, right? Then we've got these squiggly, almost like figure 8 looking lines in between. Okay, so the dark lines, that represents the inside of your wall and the outside of your wall. Doesn't necessarily tell you in this case that there's siding there, doesn't tell you that there's drywall there per se, it doesn't give you that detail, but it just defines the boundaries of the wall, right? So that part's pretty easy. So if we head to the back of the house, the first thing we're going to see here in the corner, by the way, is this box. Sometimes these are included on plans and sometimes they're not, but if they are, if you see a square like that, that represents a downspout coming off your gutter. So that's on the outside of the house, obviously a little bit off the wall. We go a little bit further back and we see electrical meter location. So you guys are familiar with electrical meters. That's used to be the disc that spun around. Today we're all fancy, we got digital ones, right? But that's what the utility company is going to use to know how much electricity that you've consumed. So we go back a little bit further and we see a dimension of 11 feet 1 inch, and that tells us where this closet wall inside bedroom 3 should be located, right? So it's 11 foot 1 inch. If we hooked our tape measure on the front of that wall, we measured back, looks like to the back of that wall, the back of that wall should be 11 foot 1 inch off of the front of the wall. That's what that's telling you. And it also then tells us from the back of that closet wall to the face of the back wall of the closet is 2 foot. And that's typical to have a 2 foot deep closet. We go back a little bit further and there's some more dimensions on length and whatnot. I think you guys get that at this point. So something new is this 32 and blah 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 by 40 and so RO. And then there's a CSMT. Well, what all this means here is that's the description of this window. So right here is a window in the wall, and that is a type of window that's called CSMT or casement window. And a casement window you guys are all familiar with, but that is a crank window. So the kind that you crank and it pivots on the side, it opens up, right? That's called a casement window. And the dimensions here are for what's called the rough opening. So if I'm a framer, I'm a carpenter, I come out to the job site and somebody says, okay, Joe, I want you to go build that, frame that wall so that we can put our casement window in there later. Well, let's pretend that the window is exactly 3 feet by 4 feet. I'm just throwing numbers at you. The window is exactly 36 by 48 inches. Well, would I build the opening exactly 36 by 48? No, nobody is that good of a framer that the window is going to fit perfectly. So usually the rough opening, the area that I build that window to, the framing part, is bigger than the actual window itself. So in this case, the rough opening is the space that is inside my studs, from one side of the window to the other and top to bottom. Now what's also confusing to students is, well, do we do the width first or do we do the height of the window first? Well, what I want you to remember, it's always width, how wide it is first, by how tall it is second. So in this case, if I'm framing this window, or this rough opening, I'm going to make it 32 and 13/16 inches wide by 40 7/8 of an inch tall. I have to maintain that, so my window is going to fit in there. So while we're here, some things that you guys probably already guessed is that this would be your tub and your shower. Well, it's a tub for sure. I can't really tell if it's a shower quite yet. I'll tell you it is. But anyway, that's your tub shower. Here's your toilet. Of course, your sink and your vanity here. The TB, those are towel bars. Now we got this funky little diamond shape right here, and it's got a letter F on it. I want you to remember this symbol. We're going to get to this later, but this is a symbol to tell you what the interior elevation of that bathroom looking towards the vanity and toilet looks like. And the diamond shape is very useful because if I put the F here, the F is pointing, if I look at that point, pointing this direction. If I put the F in this box, I would be looking at this wall. Now, if I put the F here, I'm looking at the tub. So let's work our way back a little bit further. Our walls continue. Another downspout. We turn the corner this way. Oops, too far, sorry. Turn the corner this way. We have another window. Now, this window is not a casement. It is an egress. An egress is a fancy word for escape. Okay, so an egress window means that if there was a fire or something else happened inside the house and you had to get out, you can use this window to exit. Okay, so an egress window has to be a certain size, has to be big enough so that somebody can climb out. It has to be a certain a maximum distance off the floor. So if you're in that bedroom or you're a little kid and you're in that bedroom, you have to get out. You don't want to climb 6 feet to get out. So usually I think it's like 40 or 42 inches off the floor is the maximum. So this window is 40 inches wide and 60 inches tall. And that's a rough opening. But the type of window, it says SH, and that's a single hung window, which means that it's got two sashes to it, like a double hung. There's a top sash and a bottom sash, the kind that you pull the window up. But in this case, because it's single hung, it means that just the bottom sash, bottom piece of glass with the frame, is the only thing that moves. The top one is fixed. You can't touch that or can't adjust that one. So then moving across, we got another closet. We got some more dimensions you can follow. Then we get to this black line right here with an arrow on it. And if you look carefully, you're going to see on the other end of the page, there's another corresponding black line. Now, the way I describe this is these are symbols used for what we call a building section. And a building section is if we want to know how the building's put together. So imagine this. Imagine this house fully built. It's standing right in front of you. Actually, you're like a bird. You're looking down on it now, right? Fully built, roof, siding, everything. And I took this big chainsaw. Can't think of anything better. Big chainsaw, and I cut through this house at that location. I cut all the way through here. I get down to this last one here, and I cut through that, and I take those two pieces now, and I open up that house. So I move the left-hand piece for a minute. So I take the bedroom, the hallway, and the other bedroom chunk, and I move that away. And now I stand right about here. So these two things this half the house is gone. I stand right where that sink is, for an example. And I look back at the house. I'm going to see all the components, many of the components that it took to build that house. So I cut through the exterior wall. It's going to tell me what that looks like. I cut through the fireplace. I cut through the stairs. I cut through the hallway, flooring, drywall, right? I cut through all that stuff. And now when I stand here and I look at it, I'm going to see that. And when we get to the section view, which I think is page 7. No, not that far. Page 5 or 6, if I remember right. You guys can go look at that. Let's do that right now. If we go down to section, it's this one right here. Okay, so this is section, as you see here. Now, remember that big chainsaw I cut through? Here's that outside wall. Here's the fireplace. Here's the stairway. The stairwell here. You can see the steps coming up that I cut through. The front entry, the back deck, the front porch. If you look at that in its entirety, I cut through all of that, right? And that gives me some very critical information. It tells me heights of things, dimensions this way. It tells me materials. I can put a lot of notes on it. That's what it's talking about. Okay. So let's go back up here and try to finish this. And we'll spend more time on that section view later, but that's what that's talking about. As we come across the back, we got different windows, or big windows, 106 inches and some odd wide, 60 inches tall. Next one, we got a sliding glass door, SLGL. That's that piece here, which then obviously gets us out on top of the deck. And the stairs then would go down to our backyard. Continue around the master bedroom, another window, it's egress, a bigger tub. If you look at that one size-wise, it looks a lot bigger than that first bathroom. Toilet, sink, interior elevations, another window. And here's our air conditioning unit. Obviously for our air conditioning system, that's where that outside fan sits. And then, of course, we got a garage, another casement window in the garage. They're going to locate a freezer there. And then here's something different. In the garage, we have what's called a pull-down attic stair. Now, this particular case, it does what it says. You would pull down some wooden stairs or aluminum stairs that would get you up in the attic. You don't have to have stairs there. It's just kind of a convenience thing. But what you do have to have is you have to have what's called a scuttle. And scuttle is S-C-U-T-T-L-E. That is the exact name of the opening to get you up into the attic. And that's required by code. In fact, I've said this before in this particular plan, the way the ceiling is up here, you may need a second scuttle over here. And the reason for the scuttle is so that if your house caught on fire and you had an attic up, or you had a fire up in your attic, the fireman has to be able to get into your attic quickly and efficiently, right? So this hole here has to be big enough for a firefighter with all their gear on to get up inside there to put out the fire in the attic. And when I meant there should be two of them, remember the trusses in this area here are scissor trusses. So it's a vaulted ceiling, so there's really not a lot of room for the firefighter to climb up on top of those trusses. So a lot of times a second scuttle would be needed, maybe in the hallway over here or something. Okay, and then lastly, working our way around here, we get to our utility room, washer, dryer, and our kitchen. The kitchen's pretty well explanatory, I think. You can tell that's a stove. Tell the DW is your dishwasher. Above the stove right there is a microwave. So that's the kind that sits right above there, 5 feet off the ground or whatever. We got our sink with our disposal, and our refrigerator sits right here. Now, if you wanted to know more information about how these looked, what might you do? Well, remember this thing right here, the diamond shape? Those are your interior elevations. If we would go down to interior elevations page, which I will in a second, and we would look for letter B as in boy. You see how that one points this way? We should see the stove, the microwave, dishwasher, and cabinets. Let's go find out. So let's go down, interior elevations, right here, okay? And we want to find letter B. Well, sure enough, we're looking at the stove, the microwave, dishwasher, some cabinets. It's even wide enough, the view there, that we can see even the sink sitting there. So if we go back to the kitchen, and you guys can kind of flip back and forth if you need to, that's the view we're looking at. So if we looked at A, we'd be looking at the sink. If we looked at D, we'd be looking at the fridge. So I think, that's the majority of it. Some of the rest of the stuff is pretty self-explanatory, I think, symbol-wise, but I think we covered it pretty well for this one. So we're approaching an hour here, and I'm going to try to keep the lectures to that. Like I say, if you have any questions after watching this first video, know that Bruce is available for you guys for a lecture. Room 123 at 9 o'clock on Thursdays. So if you want to hear his viewpoint, like he said in the class the other day, similar material. He may have a little bit different stance on it, a little bit different viewpoint, and that's okay. Nobody's going to look at the plan exactly the same. But we both are trying to deliver this same type of information to you. And then what I would also then say is, don't be bashful. Look at the rest of the pages. And I would bet with the ranch plan, with the exception of probably the foundation, as we get down into that, with the exception of the foundation, the rest of it should go pretty smooth for you. So be sure to take a look at all that. and start worksheet 1 as soon as you're ready. We will catch you guys next week.